Good evening, everyone. To all the students and teachers who are joining us, wish you a very good evening. And I know it's March 31st, which is the last day of the academic year. So for many of you, you're starting school tomorrow and a new session. For others, the holiday season is approaching, whatever the case may be. Hi, everyone, and welcome to our last webinar in our series of Science 101. This is webinar number 12, so the last one indeed, and we have been doing this for now, give or take, not give or take, but in fact, we have done 12 such webinar series. And this webinar, which is our last, is on vaccine self-reliance in India. So just some housekeeping items before we start. This webinar is being recorded and streamed live on our YouTube channel. To let you know about the partners, I think this should be by heart to all of us by now, but just to give you a little bit of a test, perhaps if it was something that was interactive, maybe we should have taken a test. But to start off with, USO, which is United Schools Organization of India, it's the organization that I represent, began this series and this journey of Science 101. We are a registered society established in 1951, and I think it will would love to say we are the pioneers of conducting extracurricular activities in schools nationally. We conduct several competitions, tests, seminars, conferences, campaigns, and all of these are on a national platform. Science 101 is one such very, very important webinar series that we launched in collaboration with CSIR-NIScPR. And the aim of this series was to increase awareness about science and to ensure that students have an interest in this extremely exciting field of science. Our very, very valuable partners, without very important, we could not have webinar series that we launched in collaboration. And for that, I'd like to invite Mr. C.B. Singh to tell us a little bit more about CSIR-NIScPR and also Jigyasa, which is the division that Sir is heading. So, Sir, good evening.
Good evening. Thank you, Ms. A warm welcome to the students, teachers, USO family, and the speaker today, Dr. Madhavi. It's a pleasure that Madhavi on this particular webinar series to come and join for the webinar series, and she has so happily agreed. And the topic she had selected or she is going to deliver today is in very much sync with the current scenario which has again cropped up, like the necessity of a vaccine in the scenario of increasing pandemic cases nowadays, which is happening in our country and the other country also. So a very the right time to educate the students and as well the other teachers also that how the vaccine will help in this current scenario. So this is about the topic. Now, as you all are aware that like Ms. Jan has already informed that we had been reiterating the what CSIR-NIScPR, what USO house is or a USO is. In the similar fashion, I'll again reiterate the NIScPR. It's one of the CSIR labs out of the 37 labs spread across India. And this particular CSIR-NIScPR is in the field of science communication and policy research. So policy making and the communicating the science, particularly not only to the students and but also to the youth in the form of the journals, and to the students in the form of the popular science magazines. The 3 magazines we have for the students, the Science Reporter, Vigyan Prakriti, and Science Ki Duniya, and as well we have research journals. A number of the research journals in the field of, say, biology, then physics, a number of domain has been covered for the research journals or for submitting the papers by the researcher. So this is about the NISPR. The NISPR has came into existence in 2001 and 2021 when 2 CSIR labs merged together, the NISTATS and the NIScPR, Science Communication Lab and a Policy Making Lab. They joined together and formed the NISPR. Now, as we all know that each CSIR lab has its own Jigyasa division working into it. The basic objective is just to bring in the inquisitiveness among the children that is there, that how the things work. So we try to satisfy that inquisitiveness, and we wanted to bring the children to have a more focus over the science stream as well. We had been seeing in the past also that the number of the students, they are opting for the humanities. We just wanted to focus on this particular science stream, that yes, there is the carrier in the science stream as well. It may be the reason that the students may not be aware that what is the opportunities in the science stream. They may be thinking like that, but this was one of the major objectives for carrying out the webinar series Science 101 along with the USO, that the student should come to know that yes, there is the opportunity, and there is a very good opportunity also, as they are interacting with the different scientists. Every month on the last Friday, the different scientists are coming. They are telling their research work, what research they have done. They are giving a glimpse of it to the students also. So in a nutshell, there is a vast opportunity in the science stream. So we hope that the students might have benefited for the past 12 lecture series that we have carried out. This is the concluding lecture series, but definitely we know that we along with the USO is going to find a way to keep on interacting with the students. This will not stop. There may be the different ways by which we'll be interacting with you all. This is one way. We can find it out the other way also, and we'll continue to interact and update the students also that the science is a very good stream and a field, and it's a very respectable, reputed domain. So this was all about the Jigyasa, and I hope this time the students and the teachers as well must be seeing the 2 logos is coming. One is G20 and the other is S20. You must be finding it that why this new 2 things had come up, and what does this G20 and S20 indicates. So I'll give you just a brief on this G20 and S20. So basically the G20, it's a group of 20 forum, and this particular forum is why this forum has been created. This forum has been created, it's a premier forum. This has been created for fostering the international cooperation on the topics of the global importance with impact on the growth, economy, and the sustenance. These 3 words, if we call upon, like growth, economy, and the sustenance, this is very much required by all the countries all over the world. So there has to be a mechanism by which, the certain policies has to be formed, and certain common views has to be there to work on the growth, economy, and the sustenance. So this is the premier forum, the G20. Now we say G20, then who are there in the G20? So basically, this forum has been formed by 19 countries and 1 European Union. Then what are the countries? Who are the countries who are a member of G20? It's the Argentina, Australia, Brazil, Canada, China, France, Germany, India, Indonesia, Italy, Japan, Mexico, Russia, Saudi Arabia, South Africa, South Korea, Turkey, UK, and USA. So these are the countries, along with the European Union. There are also certain, not the permanent members, but there are the, you can say the other countries also, which acts as like an co-opted countries, which is not in the main forum, but they are the co-opted countries. So this 19 countries, along with the European Union, forms the G20. Now, how these countries had come into existence, or something which has been formed or which has been decided by this G20, why is it being followed by all over the world? This is being followed because these countries represent 90% of the global GDP of the world. Secondly, 80% of the global trade is been handled by these countries, and 2/3 of the world's population. So they cater to it. That's why whatever the decision has been taken or whatever the policies has been formulated will be accepted. Now, this helps in bringing a universal sense of oneness. This is all about the G20. Now, why this is coming up? Because there is a procedure that all the countries annually, they used to preside over it. So this time for 2023, G20 presidency has come with India, and India has a tagline: one Earth, one family, one future. So this is the tagline for the India. Now, how this G20 works? There are engagement groups. Different engagement groups are there, and the engagement groups, 8 of the engagement groups are there, like civil, then urban 20, civil 20, then the policy 20. In the similar fashion, so all these engagement groups, they sit together in a country, and then they decide upon for that particular year that what should be the what should be globally viable in the case of the civil modification or civil bringing up, or the business 20, how the business should be dealt for that particular year, which is beneficial for all the countries. So this way, the this G20 works into it. And there are certain, like civil societies, parliamentarians, think tanks, they all come together, researchers, they come together under the G20 engagement groups of the countries. Now, there is another also. What is this S20? S20 is a Science 20 engagement group. It is also one of the, out of the 8, it is also one of the engagement group. And what it does is that, which supports G20 by fostering an official dialogue with the scientific community of the member state. Member state means the different 19 countries. Now, the core purpose of the S20 or the Science 20 engagement group is to present the policymakers with the consensus-based recommendation from a science-based perspective on a chosen topic of global concern. The recommendations are formulated and then by the host, the country, in which representatives of all the member academic and other policymakers take part to reach a consensus. A statement that is finally presented to the heads of the government by the host country who is chairing the G20. So it's basically formulation science, how science will help in bringing up the growth economy and the sustenance to the world. So this is the major, the objective of the Science 20. Now, for the Science 20, since India is chairing the G20, hence for the Science 20 or S20 engagement group, the title has been given as Disruptive Science for the Sustainable Development. Now, this particular is the title, which is again categorized into the sub-themes, which is like clean energy for greener and inclusive future, universal and health, holistic health. Then we have a science for society and the culture. These are the three themes in which this particular broad tagline has been divided. Now, a question comes that students and the researchers, what is expected from them in this S20 group? So this, to bring new ideas of the perspectives to Science 20 related themes and something, it is essential to spread awareness of the Science 20 to the youth of India. But how this can be done? So what happens is that what is expected from the students, researchers, that they should organize the convocations, workshops, seminars, sporting events, which could be branded as the G20 or the S20 events, seminar, quizzes, declamations, marathon, poster presentation, and other competition, etc., on S20 related themes at their institutional level. Now, these students should prepare a brief report of the outreach activity and the different activities they have conducted, and along with the photographs and the videos, they can upload to the Science 20 engagement group. It may happen that some of the ideas may be clicked by them and can form a part of the discussions at their respective level wherever the Science 20 representatives engagement group is meeting. So this is in a nutshell a small brief about the G20 and the Science 20. Now, the details, the students are so, Google friendly, they can find it out, details about each of this. So I have given you an idea about the Science 20 and the G20. For all the government organizations, it is essential to spread more, awareness among themselves, among the students, among the researchers. That's why we have bring in a concept of the G20 and the S20 here into our last webinar series. This is all from my side, and as already said, that students, don't worry, we'll again be interacting. It may happen that we may interact physically with you. Okay, so thank you, and all the best to the students, teachers, and to the USO family who has worked so hard in bringing in this, this Science 101 for such a long period of time. Thank you, Ms. Chen.
Thank you so much, sir. That was insightful, no doubt, because we see G20 everywhere, and I think students are aware of the basic of G20, but it always helps to hear about that, and especially also to understand the various engagement groups that are working in tandem of G20. So it's a matter of great pride, no doubt, that India's presidency on G20 is this year, and we are all actually witnessing history. Because 5-10 years down the line, this will be written in textbooks. So I think we need to take pride in that fact. But of course, this is a Science 101 webinar, not to mix the history with the field of science. So this is our 12th webinar, which is on vaccine self-reliance in India. And today's webinar, we are going to have, as is our normal practice, we will have a talk by a very eminent scientist. And after conclusion of the presentation, we will take the questions in the YouTube chat box. So please type your questions in the chat box at the end of the presentation. So I have great pleasure, and I'm honored to welcome our scientist, Dr. Y. Madhavi, who is the Chief Scientist at the National Institute of Science, Communication and Policy Research, which is CSIR-NIScPR, and is a biologist by training. She has a PhD in Life Sciences from Jawaharlal Nehru University in New Delhi, and has now been associated with NIScPR for the last 30 plus years on a very pertinent and important topic, which is vaccine developments in India, its impact on society, and its implications for policy. She has published 32 plus research papers in both national and international peer-reviewed journals. 6 book chapters, 12 technical reports, working papers, bulletins, 5 articles in popular media, and presented papers or participated in 61 national and international seminars and conferences. She's also worked on 13 research projects, and her work is cited by popular print media as well. So very, very important topic, I think, is now that is resurfacing is COVID-19. So during the COVID-19 pandemic, Dr. Madhavi organized a policy discourse on COVID-19 vaccine from self-reliance to global leadership opportunities, challenges, and policy imperatives in COVID era. She also organized another one on COVID-19 in children, the threats and precautions. With now the talk of cases of COVID, I think, rising again, it's very interesting to hear. So let's get an in-depth knowledge and get ourselves updated with the knowledge on vaccines. So Dr. Madhavi, I welcome you to our series of Science 101. And I now invite you to share your Yes. Yes, we can see your screen.
Yeah.
Yes.
Yeah, they are moving, no? Yeah.
Yes, absolutely.
Thank you, Neena ji.
Welcome, Dr. Madhavi.
For your warm invitation and also the kind introduction. And I also thank Dr. C.B. Singh and Dr. Suman Ray, my colleagues from NISPR, who has actually gave me this opportunity to interact with you on this platform. I am really very happy because to share my work on this platform, because I will be interacting with the young minds of India. Of course, all of you children, you are all now, I think there is no one who is not aware of the word vaccine. Everybody is very much familiar after the COVID-19 pandemic. You all must have read a lot in news and in videos also about vaccines against COVID pandemic, how they are developed, what have been developed, what kind of vaccines you are taking. But in this context, I would like to present here the history of vaccine R&D and manufacturing capacity in India. So that's how I have titled it as Vaccine Self-Reliance in India. Mind you, you are also must have read in newspapers. We have, our government has adopted the slogan of self-reliance, Atmanirbharta, to control the pandemic of the COVID-19. But before that also, India has been self-reliant since the vaccine institutions have come up in these institutes. So what are vaccines and why do we need it? Vaccines are important preventive medicine and primary health care that are used in large populations to prevent infectious diseases. And they need to be balanced with other preventive measures such as hygiene, sanitation, safe drinking water, vector control, etc. So in a way, self-reliance in vaccines is closely linked to our national health security. Curative drugs are given to a person who gets the disease, but vaccines are given to all healthy population. So once you need a strong scientific rationale and a stronger economic logic. Indian government provides free vaccination to the public at their primary health care centers of those vaccines which are covered under Universal Immunization Program. There is also selective vaccination of particular diseases where they are endemic. For example, Japanese encephalitis vaccine. Before going into our capacity, vaccine R&D capacity in India, I would like to, show you a small video on how do vaccines work to understand the immunity and what role they play, how They actually protect us from diseases. Dr. Nina, can you help me? Hello?
Absolutely.
To,
Yes,
yeah,
Dr.
to
Marg,
play the
just give me.
video. Yeah, sure.
Vaccines have an important role in protecting us from infectious disease. But how do they work? Well, put simply, vaccines train our immune system to detect and attack pathogens. And we're going to walk you through how they do it from start to finish. Our immune system is a marvelously complex network of molecules and cells, which has the power to destroy pathogens like viruses and bacteria. The part of the immune system that vaccines train is called the adaptive immune system. Its first job is to recognize an invader. In the case of this bacterium, it does this by detecting molecular markers called antigens that are part of all pathogens. After detecting an antigen, the adaptive part of the immune system starts mounting a bespoke response. B cells convert to plasma cells and start creating proteins called antibodies, which bind specifically to the antigen. Together with immune cells called phagocytes, antibodies can destroy the pathogen. The adaptive immune system also produces killer T cells, which have the ability to detect and destroy cells infected with the pathogen. But it doesn't end there. To prevent against future infections, the adaptive immune system also has a memory. It produces long-lived memory cells, which lie in wait ready to pump out the right antibodies and killer T cells if the same pathogen is ever seen again. This is called immunity. Vaccines work by activating the adaptive immune system and so creating immunity. They safely introduce antigens for the immune system to train on, preparing itself to fight real infections in the future. So what actually goes into a vaccine? Well, there are several different types. One of the most common are called live attenuated vaccines. These include things like MMR or BCG. Live attenuated vaccines work by introducing a weakened version of a living pathogen into the body. These attenuated pathogens are not strong enough to cause disease in people with healthy immune systems, but they can still trigger a strong immune response. Live attenuated vaccines trigger a similar immune response to a real infection, leaving behind the same memory cells. This means that some can provide a lifetime of protection after just 1 or 2 doses. Another key type of vaccine is called a subunit or recombinant vaccine. They work differently. Instead of a live sample, subunit vaccines contain only part of the pathogen. For instance, the vaccine for human papillomavirus, HPV, uses hollow virus-like particles made from a protein found in HPV. Alone, these subunits cannot get the immune system's attention, and so they need a bit of help from another ingredient, an adjuvant. Adjuvants wake up the immune system, triggering it to see the subunit antigens and start creating antibodies and memory cells. Subunit vaccines contain no live pathogens, and so lack the genetic information needed to replicate. That means they are not infectious and are safe even for people with weakened immune systems. Great, but generally, they don't trigger the production of as many memory cells compared to live attenuated vaccines, and so they don't provide such long-lasting protection. Training the immune system through vaccination helps to protect individuals from infection, but vaccines can also protect people who can't receive them. This is called herd protection, or herd immunity. Herd immunity is created when a large percentage of a population is immune to a disease. It works by disrupting chains of infection. Without new hosts to infect, pathogens can't survive. That means that if a pathogen tries to infect someone who is vaccinated and so immune, it dies, and the chain of infection is broken. If enough chains are broken in a population, it becomes very difficult for pathogens to reach those who would be vulnerable. Herd immunity protects millions of people around the world. But if vaccination rates drop, there is a risk that diseases can reappear. For example, measles was declared eradicated in the United States in 2000. But since then, falling vaccination rates have led to a resurgence of the disease, with outbreaks recorded in 31 states. If herd immunity is maintained for long enough, though, diseases can be eradicated completely. For example, smallpox, which is estimated to have killed 300 million people in the 20th century, is now considered extinct. All thanks to vaccination, its training regime, and the wonders of herd immunity.
I hope you all could view the video and with the sound, I think. At least you must have understood by now how our immunity system, vaccines are basically mimic our natural immunity system and protects us from the attacking pathogens and infectious diseases who constantly attack our human bodies. Now that you understood how vaccines work, want to take you to the overview of Indian vaccine scenario at glance. See, vaccines constitute
Dr.
2%.
Madhavi?
Hello. Yes.
Yes, Dr. Madhavi,
Yeah.
would you kindly share your screen again?
Okay, maybe okay. You can't see the screen. Oh, I'll just do that. Share. Now, is it visible? Hello? Can you?
Yes, doctor, it's visible now.
Okay.
Yeah.
Maybe I can full screen?
Full screen, yes. Now we can see it full screen.
Okay. Okay, now let's look at the Indian vaccine scenario at glance. Even though vaccines constitute 2% of entire global pharma industry, but they have become the growth drivers in recent times, almost for a decade. And world vaccine market is huge, which is around 24 billion US dollars, dominated by multinational companies, few multinational companies. Indian vaccine market is also huge, which is around 2 billion, growing at the 22% per year. India is one of the largest vaccine makers and buyers globally, so it is important for us to be self-reliant in vaccines. There are 6 primary vaccines which are under Universal Immunization Program of Government of India against the diseases like diphtheria, tetanus, whooping cough or pertussis we call it, and tuberculosis, polio and measles. But later these vaccines were introduced for against childhood infectious diseases in 1978 under expanded program of immunization, which is now called Universal Immunization Program. It's the same thing. This program was launched by Government of India in 1978 on the advice of WHO, because India is a member country of the WHO. WHO in 1977 advised all its member countries we should aim for health for all by 2005. For that, childhood infectious diseases should be eradicated. So all countries should at least use these childhood vaccines to bring down the childhood infections in all countries. So as a follow-up, in 1978, Indian government has launched the routine childhood immunization program. Later on in post 2000, more vaccines were added into this universal immunization program. They are hepatitis B, pentavalent vaccine, rotavirus, pneumococcal, MMR or measles, fraction of infected, inactivated polio vaccine, etc. Then who makes vaccines? Vaccines are manufactured. I mean, you have seen in the video just now, they are prepared using different technologies. The older technologies are called conventional technologies, which were made in the initial stages of vaccine discovery. Are the techniques which were used are attenuated or heat-killed pathogen. Basically, vaccines are made from biological organ, the disease-causing pathogens, either attenuated or heat-killed or toxins also. We call TT is a tetanus toxoid, DT is diphtheria toxoid, like that. And later in post-biotechnology period, with the advancement in science and technology, biotechnological applications, there was the modern techniques of production of vaccines have come in. For example, the recombinant vaccines, DNA vaccines. You must have heard during even COVID time, mRNA vaccine, subunit vaccine, viral vector vaccines. There are also tissue culture based vaccines. So there are using different techniques. Vaccines are manufactured. Now, what is vaccine self-reliance? It is reliance on one's own powers, ability, and resources to make your own vaccines in the country without depending on the imported vaccines. Is India self-reliant in vaccines? I would say yes. Since colonial period till date, it's been self-reliant. Who manufactures vaccines in India? Public sector, private sector, and also through public-private partnerships in the recent years. So if you go back to the origins of the Indian vaccine system, we have a history of over a century on vaccine R&D and production. In fact, modern medical research in India began with vaccines. Antibiotics were discovered later in 1930s, but medical research in India, prior to that, we have our traditional medical research systems, but allopathic research or modern medical research began with vaccines. India is that way an early bird in vaccines. In fact, we have been a world leader in plague vaccine. Plague vaccine was for the first time developed in India, in the world, by Hafkin in the Hafkin Institute, Bombay. So during British time, one can say we have a fair institutionalization of vaccine R&D and production. And even after independence, Indian government always took lead in encouraging indigenous vaccine development. We also have WHO support in carrying forward our effort towards self-reliance. During colonial times, this gives a table. I don't know, the font is small, but I hope you can get an idea. There were around 26 vaccine R&D institutions were set up during colonial times under different provinces they used to call, which are equivalent to states now. Whatever was the problem, they have developed vaccines indigenously for smallpox, cholera, typhoid, on anti-rabies also for rabies. So you can see a whole lot of research has gone, and these institutions were self-reliant and they made their own vaccines. There were around 26, but they have been closed down later owing to the liberalization. And prior to that, whenever there was a demand for such particular vaccine has declined. For example, smallpox vaccine. Smallpox disease was eradicated, and the announcement came in around 1970s, I think 77, like that. Then though either some of the institutions were closed down or they were restructured to produce, manufacture different products or to do different services that are related to public health. But the model which it was there for vaccine manufacturing during colonial period was our manufacturing, R&D, and the accessories which are required for the processing or production of vaccines are also under the one roof and inside the institute only for making your own solutions or animal house or blood bank. All are there located in this under the same roof. For example, I'm just cited few examples here like Pasteur Institute, Central Research Institute, Kasoli, and Hafkin Institute, Bombay. But after independence, these institutions, in fact, I must tell you that traditionally, all over the world, the vaccine R&D and manufacture started in the public sector, public funded organizations all over the world. It's the same the case with the India also. And India, though there were few companies at that time, most of them were producing drug molecules in India, except for Bengal Immunity Limited, which was only involved in production of vaccines, Sera, and anti-snake, anti-scorpio venoms and all. But in post-colonial, after India became independent, besides these institutions, the older past, R&D vaccine institutions, though very intensive R&D used to be carried out against to develop vaccines, but their R&D activity has come down is also because during the World War, Second World War, First World War did not affect them much. In fact, they have become self-reliant, and because of the restrictions on the import duties. But in the Second World War time, most of the health personnel, scientists, researchers were transferred to serve the Imperial Army. I want to give you an example. The the malaria vaccine, Ronald Ross, who has developed a malaria cycle, not vaccine, cycle, was also, he was also stationed in Pasteur Institute. He worked in Central Research Institute for some time. So they have contributed to the disease research on infectious diseases, tropical diseases, as well as vaccine development. When they all left, the resources were inadequate. So their function has confined to manufacturing of vaccines rather than giving some boost to the R&D activity. After independence, they used conventional techniques of production only because those are the ones which were available at that time, at that period. But later on, after India became independent, they were confined to manufacturing and supply for the state requirement. But at the same time, government has set up various dedicated research institutions under various S&T departments of India like ICMR, CSIR, DST, DBT, even in IITs, universities, and autonomous institutions like IIC Bangalore. So here I have given some examples, but later in the post-independent period, some companies also were there. Out of them, the prominent ones are 5 companies which also got into vaccine manufacturing and vaccine development. So this is to give you how innovative Indian vaccine public sector institutions have been, because the innovations have started in public sector, vaccine R&D institutions. This slide gives you an idea. India has remained up to date with the in technological development up to 1930s. With the developments in the health elsewhere in the world, but later there is a time gap as it gone down, and it has two implications with the war effects, also post-war effects, as well as adapting to the new technologicals of production and development. But even then, still you can see they have remained relevant. You can see, in fact, a lot of research went into the development of rabies vaccine. Anti-rabies vaccine. Rabies vaccine was particularly of concern because it was made from initially using conventional techniques, time to time different techniques of production were used, but they were virulent, they were causing virulent. So research was on to develop a safe anti-rabies vaccine. It continued to do so. Finally, we were also able to, then they came, tissue culture based anti-rabies vaccine was developed elsewhere. Even in India, we also could do it. And since 1978, since the launch of Universal Immunization Program or expanded program on immunization, many of these public sector institutions restructured themselves to produce TT, universal vaccines basically. In fact, Pasteur Institute of India developed polio vaccine indigenously in India for a decade and it supplied here. Measles vaccine was developed later by Indian Immunologicals Limited, but otherwise it was produced by private sector Serum Institute of India. In 90s, mostly many new companies have come up to make new vaccines. Currently, we have public sector institutions. These are the 6 public sector institutions. And this is a slide gives only to give you an example of since their inception till date, they have remained relevant. They continue to do so. This is the Central Research Institute is located in Kasoli. It has a central drug research laboratory which actually certifies all vaccines, sera, anti-snake venoms made in India either by public sector or private sector are certified here before they are released into the market. In fact, we have snake bites, dog bites is a major problem in those days, even now. So, in fact, many of our institutions are very good in developing. They have did a good research to develop anti-snake venoms, anti-scorpio venom and all. Hafkin Institute is one of the pioneers in anti-venom research and development. For anti-rabies, Pasteur Institute, Kunur, also there, which also that in fact in the modern technology, tissue culture based technology came later. Anti-rabies vaccine against dog bites. It also could develop in its own institute. BCG Vaccine Laboratory, it was set up in 1948 and it also manufactures BCG vaccine for cancer therapy. Initially, we were not self-sufficient. It was not enough for us what BCG Vaccine Laboratory was producing. We used to import, but by 2001, we have become self-sufficient. It was supplying to entire country. The BCGVL was the only lab. But later on, private companies like Green Signal Biopharma, they all came up in 2000s. And in 90s, late 90s, 2000, even Serum Institute of India also started manufacturing BCG vaccine. This is this table gives you indigenous technologies developed by private companies. Like I was mentioning, most of them, in fact, the modern techniques of production of vaccines has actually transformed vaccine industry from radically. The role of public sector has been reduced now and the decline of public sector and there is a rise of private sector. They are also interested in investing in R&D of in vaccines. So you can see Biological E Limited was long ago in 1953 it was there and Serum Institute of India came up in 1966. A Pune-based private company. It was actually formed with the erstwhile employees of from Hafkin Institute. And then later in 90s, mid-90s, we can see Shanta Biotech, Bharat Biotech, Zydus Cadila. Cadila was there earlier also, but it used to make drug molecules, but it also got into vaccine R&D and manufacture. So these are the main prominent companies, and in COVID, they more companies have joined when it came to COVID vaccine production. So then coming to the more recent developments during the pandemic, This slide gives you how our S&T departments were actively involved in the R&D to come back to meet the challenges of COVID pandemic. The research carried out in all these departments in various institutions under CSIR, DBT, ICMR, IIT, DST, and independent institutions also. From this bar diagram, you can see vaccine research is carried out by ICMR, followed by CSIR, and then DBT institutions. They are the major contributors. And DBT BIRAC also provided a lot of funding. DST also gave a lot of funding for all the three categories of research activities carried out in these institutions. And this pie chart shows the percentage share of R&D activity gone into therapeutics, diagnostics, and vaccines. This study is done by NISPR in 2021 to 22, one year project. We have compiled the data and try to see the Indian efforts to realize vaccine self-reliance. And if you look at the vaccines, this particularly for vaccine pie chart, we could find out as on date on March 22, that time the candidate vaccines ongoing research was around 33%, and the potential vaccine candidates were 44%, and 22% were under clinical trials. And around 15 pharmaceutical companies were engaged in COVID vaccines. Out of them, 12 are private sector and 3 are from public sector. Just to give you a latest figure, as on March 2023, 12 COVID vaccines are approved for use in India. This is just to show you a map, where the R&D activity is concentrated in India. It is concentrated in southern part of India. And coming to indigenous COVID vaccines developed in India with indigenous efforts are the following. Covaxin, all of you are aware and read, and this is completely homegrown vaccine with the strain obtained from ICMR's NIV Institute, the virus strain with which Bharat Biotech, Hyderabad-based company, has developed a vaccine. And it's a basically public-private partnership with the tremendous support from the government of India. And later you can see Covaxin was developed. It's a wholesale inactivated vaccine. This table gives you the technologies used by different vaccine developers. This table also shows you because otherwise in vaccine development, research and development, by the time it starts from the identifying candidate vaccine to reach the market, generally it takes to 10 to 15 years. But during the pandemic, developing a vaccine which meets safety standards, efficacy standards is much more challenging, and it's quite difficult also, because you won't be able to look at the long-term effects of the vaccine, whether it is working or not, and also the access to the technologies. How do you develop? Where do you get the technology? And so during this time, because we have to develop vaccines within a short time, companies have looked for collaborators where there is a capacity, expertise or technology expertise to develop technologies. So you can see from this table, there is a public-private partnerships, public-funded research organizations, and collaborations between companies, medical colleges, and also you can see. But because we have to meet the large number of doses to meet the needs of the large population of India, we had to need to manufacture them in a voluminous of doses of COVID vaccine. So there are companies like Reddy's Laboratories. This is one example I'm saying, but they have also manufactured Sputnik V vaccine, which is the technology of Gamaleya Research Institute. I just cited one example, but this gives you a picture that because of public-private partnerships, collaborations between academia and industry linkages could actually lead to the development vaccine, COVID-19 vaccines development within short time. And this is just to show you a map of linkages of different S&T departments, how they have formed linkages with industry and academic institutions to meet the goal of combating COVID pandemic through vaccines, through the development of vaccines. So factors that have contributed to self-reliance in vaccines are we already have inherent strengths in our public funded R&D institutions. So it is basically the consolidation of inherent R&D in public funded institutions and our manufacturing strengths of Indian vaccine companies. So optimization of existing expertise, experience, and expansion of capacity building for R&D. Also, Indian government tried to make these companies self-sufficient in the accessory materials, raw materials for the production and process of these vaccines. There was a shortage for a short while because we were import dependent for raw materials to make vaccines. That attempt also has been made, and government has given a lot of funding to the private companies, especially the Bharat Biotech and the Serum Institute of India. I am sure you all must have taken the vaccine Covishield, most of you, and Covaxin. So they were made using this academia industry linkages as well as support from Government of India. So there is a strong policy support which has driven self-reliance in COVID vaccine development. In recent times, it is the public-private partnerships which, along with GOI's extensive support, has played a significant role in achieving in self-reliance in vaccines. In different times, with different kind of support, India has remained self-reliant with our strong R&D capacity and production capacity in India. Thank you very much for your patient hearing. I'm happy to interact with you now.
Thank you so much, Dr. Madhavi. That was really very insightful. And given the fact that with COVID, I think our awareness also on vaccines and vaccinations and all of that has increased. So that was very, very good for us to know. And now we'll open the floor for some questions. So the teachers and the students who are joining us on YouTube Live, please type your questions in the chat box, and then we can get the questions answered. So I'll, given that I am, online now, I'd like to ask you a question, something that is a, for lack of a better word, something that goes around a lot among people. And that is, during COVID-19, there was vaccinations that everybody needed to take. But then, is it better to take a vaccine, or is it better not to take a vaccine? I think that was the question that was going on in the minds of many people. So just want to sort of ask you in terms of, in scientific terms, vaccines are, of course, very important to help keep us at bay as far as the disease is concerned. But what is your view on that?
Right. You have actually reflected the question which has come up in each one of us, even including myself. All of us thought about it because of lack of data, the systematic reviews, because for short duration the vaccines were made. Everybody thought about it, but because in the midst of pandemic there was a lot of panic, it's better to take a vaccine rather than not to take anything else. also there were also, I mean, assurances from scientific fraternity that at least it doesn't, at least COVID-19 vaccine was found to whether it was not able to stop the disease spread, but it was able to reduce the severity of the disease. The deaths which were rampant during the second wave only, no? That was in 2021, has really created a lot of panic. So we had to take, all of us have taken, even then some of them, this dilemma was there in everyone's mind. Even now it is continue to do so, not only in India, all over the world. This is what has been done. Now I think vaccines long-term effects are also important to assess long-term effects. And we didn't have enough time. But even then, while the vaccination is going on, I think one needs to do follow-up studies. This is that's where one can actually document and also maybe rectify and see what can be done in future and how one can make them work better. I mean, that's how I look at it. That's how I put it. I hope I answered your question. Even now, yes, the data is coming. Actually, the data is coming now. Even many papers are being published about Covishield also. In principle, actually, Covaxin should have been better because it's a whole cell vaccine with a highly mutating vaccine like this SARS-CoV-2. One would expect that it would protect various mutations, but still I think enough data has to come to realize its significance. So, I mean, to actually look at the data once again and come to conclusion. That's how I look at it. Thank you. Hi, Nina.
Yes, ma'am. And how about booster shots?
Booster shots also, whatever information, I mean, even among people, whatever I have seen, some people are taking it, some people are not taking it. We get to hear by word of mouth that some have complications also. So still data has to be there, data has to come. Unless there is a systematic analysis of data, it is very difficult. I mean, to comment anything on it actually right now.
I see.
I mean,
now in terms of the
data also, I can't say anything except for that I'm also, as much as you people are aware, whatever is being informed by the ministry, that's what one go by. But still, people are apprehensive about the doses. I mean, apprehensive about booster doses. It's maybe that could be the reason why there is no uptake, unless I think maybe the data, maybe we need to provide the data on safety of data, whatever, in the public domain. So maybe people get confidence on it. Or maybe scientists maybe need to communicate very clearly the pros and cons of the vaccines which are made. Or whenever the data comes, because there is also, when you are giving it to large masses, you have to see the cost benefit analysis also, based on that tools are being utilized now, but that is one part, and that in that one has to factor the safety efficacy issues also. So maybe analysis of a statistical significance of data available will help.
Right.
Yeah.
And in terms of the types of vaccines, you just mentioned maybe Covaxin would have been a better type of vaccine because it was more wholesome. So in the different types of vaccines, how do we sort of, when we go to take a vaccination, nobody tells us which type it is. So how do we make that determination?
No, they were telling it is Covaxin or Covishield. No, when we went to take vaccine, we were told this is COVID
Yes.
vaccine and Covishield. Sorry for that.
Okay.
I
All
mean,
right.
sorry,
I
I'm
think in
for my call which has come. I'm very sorry. Okay.
that's
Mm.
okay.
Uh-huh.
Yeah.
Yeah.
So I think in terms of questions, Dr. Madhavi, that's all that we do have.
Oh,
Um,
no, none of the students.
yeah, I think vaccination and
I hope there are enough. They are listening to it.
but they are all online.
Yeah.
So they are indeed listening to it. Um, and I'm sure that if there are any other questions that come in later on, then we'll
Yeah,
have
sure. They
you
can write to me also
ask
directly.
them.
Yeah. If they
Yeah,
have any further queries. See, whatever you
right.
have question asked, they are relevant and that is there in everyone's mind. But what I believe
Yes,
is if there is a, I mean, data available for all this, then maybe, and we have to build in public confidence in vaccines through the, I mean, explaining about pros and cons of vaccines. Even COVID vaccines are also very important to gain public
indeed.
trust. That's how
Yeah,
I
yeah,
get it. Yeah.
right. So I want to thank you so much, Dr. Madhavi, for taking the time and giving us this very insightful knowledge. We had the last session that we had was on information. There's a lot of information around us, but it's very difficult to find the right information from the right source. Otherwise, it's like everything is someone says something and it's like Chinese whispers. At the end of it, it becomes completely something else. So it's very valuable coming from you. Thank you so much for taking the time for sharing your presentation and also helping us sort of understand the world of vaccines a little bit better. So, for the benefit of all the teachers and the students who are online, as I mentioned earlier, this is our last webinar in the series. I am sure that some of you will greatly miss these sessions because every time that we had these webinars, it was on a completely separate and different topic. And before we conclude for the evening, I just want to say a huge thank you to the teachers who received the links and duly just forwarded them on to the students. To the students who, in spite of their busy schedule of having evening tuition classes, extra classes, exams, tests, and whatnot, made it a point to attend. Many of you, in fact, even have watched the videos later on. So thank you so much for doing that because this will really help you develop an interest in this field of science. To our, I say, friends and our colleagues and our partners at CSIR-NISpR, we have been working very closely with Mr. Singh, Dr. Suman, Dr. Farhat, Ansari ji, very, very closely with all of them. And I can't thank them enough for the perfect coordination that our teams have in terms of when do we need to do the next webinar, who do we identify. There's a lot of work that goes on behind the scenes, and that can only be done when there is perfect coordination, which I am so proud to say that we share with CSIR-NISpR. So thank you so much to all our friends and colleagues at CSIR-NISpR, to the wonderful scientists who, in fact, used this platform and shared their knowledge. This is extremely valuable. I hope the students recognize the time and effort that has been undertaken in this exercise. The scientists that you heard from, each one had a different area of expertise. Each one was unique and they all brought in their knowledge just to share with you all. So what you got was very good and valuable information. So I want to thank all the scientists. Dr. Madhavi, I hope I take the liberty in saying, you can accept the thanks on behalf of all the other scientists who came in for the webinar series. And lastly, I'd like to thank my team. As I said earlier, and I mentioned earlier, in order to execute this on a monthly basis like clockwork, ensuring that there is no glitch at the last minute of the webinar, ensuring that it's being aired properly or the link is right. And of course, none of us come with a downloaded manual on technology. We are all learning as we go along. So my team is my biggest support, without whom we could not have done it. So I really want to thank Jolly ma'am. I also want to thank Adarsh, who makes sure that this happens like clockwork. Jolly ma'am is on her toes, telling everybody that this is the webinar series and so on. So thank you so very much. And want to tell all the schools that the entire webinars, all of the webinar series that we have conducted since April of 2022, including this one here, are on our YouTube channel. Links will be forwarded to you by tomorrow. Kindly forward them to the students. Please let them go through these links, gain the valuable insight. Maybe there's an interest that is created in a child and who wishes to pursue science in higher classes as well. And if any one student even becomes a scientist, I think, Dr. Suman, if you're here, or Mr. Singh, if you're here, it'll be a matter of great pride for us. We will feel that our job is well done. The aim is just to make sure that you understand that science is indeed a fascinating subject. So since we are on the platform of YouTube, I must say, please do like the videos and do subscribe to our YouTube channel. And with that, it concludes our last webinar in the series of Science 101. So once again, just want to thank everyone, whoever's online and whoever will watch the videos later as well. Thank you so very much for staying with us. We are a Science 101 strong family community. So great. Thank you. Thank you, Dr. Madhavi. So we'll sign out now.
Thank you, Neelaji. Yeah. Thanks for everything. I thank my colleagues also. It's wonderful being on this platform. Only thing is I'm hoping tomorrow, in future, maybe students will interact with me.
Of course, yes.
It's been really wonderful to be here and interact with them. I hope so in future. Yes. Thank you very much for your coordination and to your team.
Thank you.
Thank you.
Thank you, Dr. Madhavi. Have a good evening, everybody, and all the best for your new standard, your new grade. Study hard and enjoy yourselves, and we'll see you in the next academic year. Thanks, everyone. Bye.
Bye. Bye, ma'am.